Hopefully people can see a Commodore 64 Basics version 2.
You are fine.
Outstanding. That's the last year ever did. Oh, sorry. So, I am here to give a hands-on review of a new fourth, well, not really new, it's actually been around for many years, new for me, fourth interpreter for the Commodore 64 platform. As you can see, this is version 5.0. And what I'm going to do now is I'm going to load up my talk. I remember what it's called. And I'm going to use Forth to give the presentation itself, as I typically have been known to do in the past. Actually, this is the first time I've done it since Haskell 2. Got a few minutes here. There we go. All right. So what is, well, first of all, who the heck am I? I'm Samuel A. Falvo II. I'm the computer project guy from years past. I kind of had life getting away, got married, got new jobs, got laid off, got new jobs, got laid off, got new jobs, you know, that whole Silicon Valley lifestyle thing. And I ended up falling away from the Forth community for a while, but I'm coming back to it. Things, hopefully, knock on wood, are starting to stabilize. And so I hope to be back into the fold in the future. So what is DurexForth? Well, it's a Forth 2012 environment for the Commodore 64, and it replaces BASIC entirely. So entirely, in fact, that if I hit the restore key, it drops back into the OK prompt. And there's a reason for that, which I'll get to shortly. The first is the kernel and the editor and the assembler, I forgot the list there, take up about 12.5 kilobytes starting at 0801 hex, which is your basic start address. And the return stack is your CPU stack, which means that this is a subroutine threaded Forth, not the direct threaded, not indirect threaded, subroutine threaded, which is nice because this Forth is nice and fast. So fast, in fact, that I was able to pull the raster compare register and get a relatively stable, color change right about at the bottom of the screen here, without much flicker, without interrupts, just pull, which is awfully difficult to do in Blazing Forth or 64 Ultimate Forth, or I forget the exact name. Primarily because of the overhead from having to do the direct threaded indirect. It is also tail call optimized, which is, as far as I can tell, unique for a 17-threaded Forth, certainly among my own Forths. And that has implications if you do weird and crazy things with the return stack like I like to do. As you can see here, I've got a portion of code here, which if you were to run it right now, wouldn't necessarily crash the environment. But in a real working program, you run the risk of causing corruption in the dictionary space. So best to avoid that. There are ways that you can work around it. Primarily, just make sure you don't hard drop from a word that is in front of a semicolon. This does have a couple of demos, which I will be happy to show you if there's time afterwards. However, because of the wonderful speed of the Commodore 1541 floppy disk drive, that can take some time to load. So I'll defer that until the end of the presentation if there's enough time. If you're interested after the presentation, feel free to see me, or you can go on PygmyForth, which I forgot to put a link in this, but before I put this onto the generalities mailing list, I will include a link to the GitHub repository that you can grab this from. This is all open source. And as you probably noticed from me scrolling around here, that this is not a block-based system. In fact, there are no block words defined. In fact, there are no file words defined except for those unique to the Commodore 64. So you've got check in, check out, open, close, device, clear channel, that sort of thing. And as a higher level abstraction, you have load B and save B, which probably will suffice for 99% of what we're looking to do. And as I mentioned earlier, it does include a 6502 assembler as well. Some interesting technical stuff about this Forth. It separates out the dictionary headers from the actual code and data space, which is awfully convenient because it allows you to hide any word you want, including system words. So if you want to hide drop, you can do it. I don't recommend it. It makes using the system very difficult. But yeah, you can see here in the diagram, code data starts out typically right where basic source programs start out. It even has the whole, SYS 2061 header. But the here variable, or I should say value, that points to the first piece of free dictionary space that you have at your disposal. The word latest, which is another value, that drops towards here. So in other words, here grows up, latest grows down. And when the two meet, that's how you know you've run out of space. Need to know how much space is available for you to play with? Latest here minus dot. It's that simple. The name tokens themselves are variable length entries in the dictionary. Names can be up to 31 characters long. I've illustrated the drop word here. And I've also blown up the length byte as well, because there are some bit fields involved in there. You have the immediate flag, and there's also enough space reserved for 2 additional flags that are currently ignored. And I found this out empirically because there's this thing called destructive testing, which I did to basically deliberately. I defined a word and I set one of those bits, and it didn't have any effect until I hit bit 4, at which point, yeah, all hell broke loose. But in most Forth systems that have name tokens, there's a word called NT to XT, which allows you to map a name token to an execution token. Clearly, this functionality must exist somewhere in the dictionary, because you can define colon words, right? However, it is not public. Somewhere this code is hidden. And so what I did was I basically included here, if you need that functionality, this is the definition for it. Basically, you just skip over the name and just read out the for that. The facilities that come with DurexForth is actually fairly complete. The text editor that comes with it is called V. You've seen me launch this file with it. It is based on VI, but there are still nonetheless many differences. V, for example, can edit files up to 11 kilobytes, not 11 gigabytes like Vim. However, it is trivially easy to crash the entire Forth environment by just pressing the dash key in command mode in this editor. It is an outstanding bug. I filed a bug report for it. Once I feel motivated to, I intend on fixing that bug and providing a patch. Unfortunately, time has not been on my side for that. However, it is high on my priority list to do. Same for the equal sign. If you push any of those keys, you will cause irreparable damage to the dictionary. The editor supports running the contents of the buffer, which does not necessarily need to be saved. By just pressing the F7 key. You press F7, it will actually compile the buffer as though you had included it. This has implications for how you go about working with the environment, which I'll get to in a little bit. The workflow is actually pretty smooth once you're used to the boilerplate needed to set it up. It does come with a DOS module, which is not pre-compiled in by default, although you can turnkey the system if you really needed it to be built in. You access it via the include DOS command. And that will give you command line access to the disk operating system that runs on Commodore compatible storage devices. So for example, if you wanted to rename a file, you would use the R0 : new name equals 0 : old name syntax. It's kind of backwards from what most people conventionally think of when they think, oh, this is a command to rename a file. But when you think of it in terms of variable assignment, it makes more sense. Most Commodore DOS implementations have a small handful of useful commands, which can be conveniently accessed using single letters or their full name. I've included 5 of them here. Anything that you could typically do with an open 15,8, 15 magic incantation in BASIC, you can do using this DOS command. You also get a disk directory with the ls command. I'll easily demonstrate that now. I will show you selecting disk unit 8, and I'll just type ls. It will attempt to read the directory, and it will automatically page it for it. Okay, so, and you'll notice that the graphics file is 44 blocks, which is about 11 kilobytes. And the graphics demo that uses it is another 5 kilobytes on top of that, right? And so when you consider that 1541 transfers about 1 disk block per second, you can imagine that is the longest loading demo ever, which is why I'm deferring it to the end of the talk if I have enough time. If I access V without giving it a file name, it will just reuse the existing text buffer. So between ls, DOS, and V, you basically have a pretty productive development environment, which leads us into the workflow that I've come up with. So DurexForth encourages a workflow that is centered around the editor, as you can imagine, thus making it somewhat similar to things like Smalltalk or Lisp or what have you. However, because of the way Forth works, you manage your dictionary space like arenas, what's called arenas in C programming. And so therefore you need to use marker words everywhere. Sprinkle them in your source code liberally. You will thank me for it. For instance, the start of a module typically starts with a marker, and then the new marker word that redefines it. That basically is the equivalent of, like, if you're familiar with ColorForth and the word empty, that basically has the same effect. So to give you an example, I'm actually working on a implementation or a clone of Space Invaders using this Forth environment. And I can basically give an illustration of that. Right. So at the very top, you'll notice that I've got invaders with in equal signs. That basically is the invocation of the marker word that cleans up the dictionary space up to that point. I then redefine a marker for invaders that demarcates the part of the memory where I'm dedicating it to invaders. And then down towards the bottom, I want to talk about something else. And that is unit tests. As everyone knows, or as everyone who knows me knows, I'm a big TDD fan, test-driven development. And so basically, I embed unit tests directly into a module. So they run every time I load the module. And I use marker words here as well, so that I define a marker called end tests. I then define all my individual tests. They do their things, and then I call end tests to clean up the dictionary space, and all the test-related code goes away. So as far as including the module, it's basically production code. But every time you do include it, it automatically runs tests. You just never know it unless a test fails. Let me get back into the code review script here. I'm sorry?
Was it on device 9?
It is on device 9, yes. I gotta scroll down to where I was. Okay, about where I was. Oh, yeah, so this kind of illustrates the structure of a module that I've basically come up with. You have your marker, you redefine the marker. You basically have your constants for that module, define private words, define public words, and then you include your unit tests in suitably demarcated. By the way, you'll notice that there's no backslash. And that's because the Commodore 64 lacks a backslash character. Its character set was determined by the 1965 version of ASCII, where instead of a backslash, it has a back arrow and a up arrow. In this dialect of Forth, or I should say, the folks who wrote Durex decided to use the pound sign, which conveniently on an IBM compatible keyboard running in this emulator maps to the backslash key. But yes, pound is officially the common character for this. Of course, parentheses work as well. So yeah, my conclusion. DurexForth is easily now my second favorite Forth environment, coming in immediately after PygmyForth. And despite being very easy to crash if you're not careful, DurexForth is actually small and comfortable enough. You can pretty much resume where you left off after a crash pretty easily. And since it replaces BASIC, it has no underlying host OS to rely upon, so it must become the OS. And you can tell, it feels it. It's very complete, it's very cozy, and it works with grace, convenience, speed, minimalism, and it doesn't compromise on features or system level access at all. 10 out of 10 for me. This is easily my favorite Forth on the Commodore platform. So, any questions? Yes.
Can we write it to a cartridge?
It has support for that. So the question is, can you write it to a cartridge? I want to give a qualified yes. There's discussion of it in the documentation. I think that there's instructions on how to do it. I myself have never tested it. I just use it from the disk. The default build size is about 12 and a half kilobytes, as I indicated. If you do use a cartridge, you're limited to, I want to say 16K thereabouts.
It barely fits.
So it barely fits, but you've got plenty of space for sure.
Excellent.
So what I'm going to do now, I'm going to try graphics demo. Okay, so I'm going to do include demo. I'm going to turn on warp mode so that we can get through this load process conveniently. And I'll start the process. I probably won't have enough time to finish the demo, but this should give you enough understanding of how fast the system works. So that's its line drawing performance right there. So not too shabby. I've seen games go slower than that. This is like a starburst pattern. I'm going to work through the rest of this because basically it's more of the same. I should also point out that the text editor buffer is in memory the whole time, right? So even though we're working in like high-res graphics modes, which is like an 8 kilobyte buffer for the bitmap and another kilobyte for the color nibbles and all this stuff, they still managed to keep the 11K text editor buffer separate and distinct from the dictionary. So if something in this graphics demo were to crash, for example, I could still type v graphics demo, go in, edit it, and rerun the demo from there.
Oh, that's Amazing.
So they actually do pack quite a bit of functionality into the 64K memory space. The one thing to note though is all the 0-page locations that were formerly dedicated to BASIC are now occupied by the data stack. So all of those, that's one of the reasons why it cannot revert back to BASIC. It's physically infallible unless you were to somehow cache, the 0-page locations first, which it doesn't do because that's just a waste of effort. But I think some of these demos make use of turtle graphics. I'm not entirely sure. I haven't really studied the source code that much. And so this demonstrates the area filled performance.
Now, it looks like some of the LucasArts vector graphics they did for some of their games that I have.
I'm sure there's some inspiration there for sure. This one takes an awful long time to load. I don't understand why, but so basically, you can very easily, if you're familiar with King's Quest or something like that, very similar drawing algorithm. So like if you were to try drawing these in BASIC, it would take 50 times as long at least. That's the demo.
Awesome.
I was about to type 5 before I realized here's
But if you hit what is it, the dash or hyphen or something?
Oh yeah. This is what
Crash
happens.
it.
So I'm running in command mode. If I hit dash, boom, crashed. Oh yeah.
That's awesome.
Just the podium from Doug. Doug, you're up.